we are on our notes in P5, and so I think we're finishing 5B. So I believe we've probably already factored it out. I'm sorry, I don't remember exactly where we were, or we've distributed. And then I want us to move 13 to the other side. So we're gonna have put minus 13 on that left-hand side. It says to solve using the quadratic formula, and so that's what we're gonna use. You should probably have yours still written up there. Mine's erased from doing it so many different times, but I can still remember it, so that's okay. X equals negative b. Let me label A, B, and C. Where's Cleva? Okay, I think most of us are here now. Negative b, so that's negative 5, plus or minus radical b squared, so 5 squared, minus 4 times a times c. A is 1, c is negative 13, and that's all over 2 times a, which is 1. All right, now we just start simplifying. I'm going to do 5 squared, which is 25. Negative 4 times 1 is negative 4. Negative 4 times 13 is a positive 52, I think. And then 2 times 1 is just 2. I'm going to combine what's in my radical. So I've got x equals negative 5 plus or minus root 77 divided by 2. And I have to ask myself, do I simplify that root 77 or can I simplify that root 77? If I want to do like a little factor tree to the side, that's 7 and 11. Well, those don't have any like further factors. So actually root 77 is as simple as it gets. And so then that means my answer is best right here. Negative 5 plus or minus root 77 over 2. Okay. All right, let's go back up to letter A. Also, my iPad's kind of on a delay, so that's why it's kind of like not glitchy, but it's not moving smoothly. So I'm recognizing it. I'm trying to go at a pace that is not too crazy, okay? But if something's funny on your end, just tell me. Okay, so letter A looks way more complicated. It's just all the simplifying before I can even do the quadratic formula. So let's do my distributing this x on the right-hand side, combine all my terms over there, and then I'll move everything to one side. So I've got 3x squared minus 6x minus 7 equals x squared plus 3x. I can't do anything with those guys yet. Distribute that x, and I've got minus x squared minus x, and then that plus 3 is just carried through. Now I'm still on the right side. I'm just combining anything I can over here. X squared minus x squared. Well, those guys go away. 3x plus x is 3x minus x is 2x, and then that plus 3 is by itself. So I've got 3x squared minus 6x minus 7 equals 2x plus 3. Now I got to move the 2x and the 3 to the other side. I can't have them on separate sides and do the quadratic formula. So minus 2x and minus 3. I get 3x squared minus 10x. Nope, minus 8x minus 10. Got a little excited there. All right, now that I'm here, I have A, B, and C. So let's label A and B and C. And now we're going to plug it into our quadratic formula. So I've got x equals negative b, so negative 8 is a positive 8, plus or minus root negative 8 squared minus 4 times a, which is 3, times c, which is negative 10. All of that is over 2 times, 2 times a, which is 3. Okay. All right, I don't know what's happening because you can't see my thing. I'm gonna stop it for 1 second. You guys keep simplifying through. My computer might be tired from doing too much. Okay, that's my face. Now I want the iPad. All right, as you're simplifying through, I'm just going to talk you through it. I'll show my screen when you can. I've got 64 plus 120, and then I've got 6 in the denominator. I can add 64 and 120. 64 and 120 is going to be 184. Yep. And then 6 is still on the bottom. I think I'm getting close. Here we go. We made it back. Okay. Just a slight intermission. Now the screen is back. And I have 184. Let's see if I can simplify that before I move on, before I say that I'm done with this problem. 184 simplifies 2 times, I think 92. And then 92 can be broken apart 46. And then 46 becomes 2 and 23. But 2 and 23 can't go any farther. So I have a common factor of 2, and then I've got 2 times 23 or 46 left back inside. So I've got 8 plus or minus 2 root 46 over 6. And then you guys remember, if I have a common factor in all 3 of these places, in the front, in front of the radical, and on the bottom, I can cancel that, right? You remember that? So I've got 4, I've got 1, I have 3. Writing a 1 is a little redundant, so I probably won't do that. I'll just do 4 plus or minus root 46, and all of that's over 3. And that's my answer. A lot of the work was to just simplify it, even to get it to be plugged into the quadratic formula, and then quadratic formula was just all that we've been doing. Okay, now let's look at C. This looks hard because I've got a little fraction in there, but it will all work out in the end. I don't even have to do any work to begin with. I'm just going to label A, B, and C, and I'm going to plug in. X equals negative B, negative 7 is a positive 7, plus or minus root B squared is going to be negative 7 squared, minus 4 times A, which is 1, times C, which is 5 over 4, and all of that's over 2A. All right, and then now we simplify. Keep the 7 by itself on the outside, 7 plus or minus root 49. I have negative 4 times 1 is negative 4 times 5 over 4. The 4's cancel each other out, and I'm just left with negative 5. Let me get rid of all that highlighter. That did not work as well as I wanted it to. The 4's cancel each other out, and I'm just left with negative 5. So even though that fraction looked like it was going to make the problem way harder, it actually was fine. 49 minus 5 is 44. 7 plus or minus root 44 over 2. And before I say I'm done, let's check and see if root 44 simplifies. Oh, this one does. It's 4 and 11, and 4 becomes 2 and 2. So I have a common factor of 2, and then 11 stays on the inside. So I've got 7 plus or minus 2 root 11 over 2. Am I done, or do I need to keep going?
Done.
Done. Thank you, Brooke. I'm all done. If this 7 was had a factor of 2, I would have to keep going, but it doesn't, so I'm going to leave it like this. 7 plus or minus 2 root 11 over 2. All right, questions so far? Okay, now we're going to do some calculator stuff. So I'm going to make my screen a little bit smaller so we can see the calculator. And I'm going to have to move all of our faces. I don't know if you see our faces, but it's in my calculator way. Awesome. Okay, this is as good as it's going to get. Okay, so we are going to solve graphically using our calculator. So I'm still looking at my screen. I'm on 5A. I need to do 2 problems. All right, I have to set this in my calculator under 2 Y's. The first one, the left side is going to be my Y1, and then the right side is going to be put under Y2. Once I plug both of those into my calculator, I can just press intersect and see where they cross each other. Okay, so that's what I'm doing for C and A. My left-hand side is going to be my Y1. My right-hand side is going to be Y2. Now B and D are a little bit different because they're both equal to 0. So I don't even have to do anything. I'm just going to find the zeros for these. Why are you not writing? So these guys, I'm going to find the zeros when I plug in, and then these two, I'm going to do the intersections. Remember, at the end of the day, both my answers are just going to be x equals. So let's look at what this is to plug in. I'm going to put my window back to normal. So I just think I'm going to do z standard, just so I have a normal window, because for the first one, I just want a normal window. I'm going to put absolute value of 2x minus 1. Absolute value is if you hit math and then scroll over to the NUM menu, then it's ABS. That means absolute value. So if I press enter there, wherever my cursor was before this, absolute values will show up. So it shows up in my y equals, and it has actual absolute values. On an older calculator, sometimes it physically says ABS and then parentheses, but on the newer ones, like most of you guys have, it's these nice actual absolute values. So now inside I type 2x plus or minus 1. And that's it for that one. And then for y2, I'm going to type in x squared. Now I want to graph these guys. So I'm going to go hit graph. And I'm going to see where the blue and the red graphs cross each other. I'm going to see where they intersect. I physically see one over here. And then there's something weird going on over here. I don't know if that's once or twice that it hits. I did find out last period it's just one time. So we're going to do one time over here to find that. But this one is also one intersection. So I'm going to have two answers, 2x equals. To do intersection, we do second trace. And you go down to number 5 and press enter. You can keep your cursor right here. There are going to be 2 zeros though. So if I don't move my cursor and I just say, all right, I'm on the first curve, enter. Okay, I'm on the second curve, enter. All right, where am I going to be? Enter. Okay, it gives me one intersection and it looks like it chose the one to the right. When I do this again, I'm going to have to cheat my cursor a little bit closer to the other 0 so it knows that I want that one as well. So the first answer, so before I move on, I'm going to write this answer down. It's 0.41. Again, I only care about the x. I don't want the y. Doesn't matter. Not important. I'm going to do this exact same thing again because I physically see another intersection. I physically see there's a place over here. Now, if I kept my cursor here, it's going to give me the exact same intersection. So I'm going to move my cursor over a little bit on my blue curve and press enter, and over a little bit on my red curve and press enter. And now I'm closer to that 0, so it's going to give me that 0. So if there's more than one, you may have to move a little bit to get to the intersection that you want. I found the first one was 0.41, and then this one is negative 2.41. And just from experience, I know that there's no more over here. You could try again if you thought that there was more than one intersection. I know there's not, so we're not going to waste time doing that. Okay? Let's do letter C because it's also an intersection. So let's do letter C together and then we'll do the zeros. So I'm going to go to y equals and I'm not even going to clear out that absolute value. I'm just going to manipulate it to be x plus 1. So I'm just going to delete the 2 and make the minus a plus. All right, that looks like what I want it to look like. And then the second equation should be 2x minus 3. So 2x minus 3. Oh, I got to delete some of this stuff. Oh, I should have just cleared. That was my bad. I should have just cleared that one. 2x minus 3. Now it looks good. Okay. Now I'm going to go back to my graph and I'm going to intersect and see where they cross. Beautiful. They just look like a very clear one time they cross. That makes sense. Absolute values are that V, and I physically see that V. And then the other one's a line. This guy is a line. It's a linear equation. And so I know that it's only going to do that. There's nothing curvy happening off the screen. So I'm just going to find that one intersection I see right here. So again, second trace, intersect, enter. That's my first curve. That's my second curve. Since there's only one intersection, I don't have to move my thing. It automatically finds that it's at x equals 4. Awesome. All right. Let's do the zeros. Let's do B and D. Same thing, but I just have one equation on both of these. So I'll clear these guys out. B is going to be x raised to the 3rd plus x squared plus 2x minus 3. Oh no, I'm all on the exponent. Make sure you're not like that. 3, and then I got to click out. Oh, that was annoying. Plus x squared plus 2x. All right, and then we're going to go to graph. I hope my graph is good. Awesome. We'll talk more about this later, but this to the third means that I've got a cubic function, which means that it does kind of make this little S shape, and the only place that I'm intersecting is the one place I see. There's nothing else happening outside the graph, so that's good. So I'm going to find that intersection. So I'm going to go to second trace. I'm not finding the intersection, I lied. I'm finding the 0. I'm finding where it intersects with the x-axis. So I'm doing 0. And I'm going to say, this is left of it. Good. I'm going to scroll over a little bit to find the right of it. And then I'm going to scroll down to actually find the value. So I'm going to say enter. This only had 1 0 because of how it was graphed. And so I'm going to say x equals 0.84. That's it. We got one more. Now I got a square root one. Any questions so far? Doing okay? Okay. I'm going to do y equals, erase that. I'm going to do x plus 2 minus 2. Now to do my square root, remember that's second x squared, and I'm going to put x plus 3 inside. If you have an older calculator, you may need to end with parentheses, but mine knows that I am ending it already, so I don't need to do that. All right, let's press graph. All right, now I see my intersection. So let's go do second trace. And I'm going to go to 5, which is my intersection. Enter. Nope, I lied. Ugh. I'm sorry, guys. I'm like all mixed up in my words. Okay, I got my y equals. I don't want the intersection. I want the 0. I want to know where it crosses the x-axis. So I want 2, not 5. All right, left bound, yes. Right bound, yes. 0, yes. Okay, so my 0 here is 2.82. Seems fine. There's no other points. That's all good. Any questions so far? Graphing is pretty self-explanatory. If this is hard for you, I know that you guys hit it really hard in Algebra 2, so please feel free to like ask me to go over it or slow down or spend some time in Flex getting some help from me, because I know that you hit this hard already and I want to keep moving on with class. Okay, we're going to move on to some book problems. So we're looking at our book in section P5, and so it's in my book. My book pages are not the same as this is written here. So I'm actually on page 47. I just went to the P5 problems, and we're looking at 59 and 60 and 61. So you guys can see the book problems. You guys can see the calculator. Let me get the iPad screen back up so you can look at the screen too. There's a lot of screens going on. All right. Okay. So this first question, 59, asks about the size of a soccer field. So some World Cup games were played at Stanford back in 1994, before any of you guys were born. The field is 30 yards longer than it is wide, and the area is 8,800 yards square. So we want to find out how big the soccer field is, what the dimensions are. So as I tell my geometry kids, whenever you're in doubt, draw a picture. So I have a picture. I've got a soccer field. I know it's a rectangle. I know that I have one side is my width and one side's my length. And I know that area is the same thing as length times width. Now let's use some of the numbers that were given to us. We know that the area is at 8,800 or 8,800 feet. So I know area is equal to this number. And then it also tells us that the field is 30 yards longer than it is wide. So longer, that's referring to length, 30 yards longer than it is wide. So I'm going to keep W as my variable, and length is going to be whatever my width is plus 30. My width plus 30. Now that I have everything written in terms of W or a number, I'm just gonna plug this into my basic area formula, and then see what I can solve for W. So over here, area equals length times width. Well, area is this 8,800 feet. Length is width plus 30. And then width, we're just going to keep as W. I am going to simplify this right-hand side, and then we have some options. So I'm distributing 8,800 equals W squared plus 30W. Okay. We have two options right now. We can either stop here and find the intersection between these two lines. I can label the first one as Y1 and I can label the second one as Y2. Or I could go one step farther and bring the 8,800 to the other side and have 0 equals W squared plus 30W minus 8,800 and have all of this just be my Y1 and then find the 0. No way is more correct than the other. No way is wrong. It's just whatever makes you happy. Which way do you guys want me to do it? Does anyone have a preference? Intersection versus 0? No preference? Okay, I'm just gonna do intersection. I'm gonna cross this out. I'll have x squared. Remember, we can't have other variables than just x. So I've got x squared plus 30x. And then I have 8,800. The thing is, though, I'm going to have to change my window. So I'm going to go to window right now. My x value is in terms of width. So my width can't be any negative value. And it says 30 plus something. Let's try like 100. I don't know. It might be shorter than that, but I don't want it to be much bigger than that. I want to try and aim big and then just have to zoom in later if I need to. So I'm going to try 0 and 100. And then for my y, that's my area. Well, I know that this value right here, one of my y's is 8,800. And so I should probably go from 0. I can't have a negative area, but I probably should go big. I'm going to go 10,000 for my area and see what happens. All right, graph. Okay, beautiful curve, beautiful straight line. Easy. I see my intersection. It's very clear. Let's do second trace intersection because I'm looking at 2 points. There's my first curve, there's my second curve. I don't even have to get any closer. There's only one place they cross, so it's gonna tell me that it's at 80. So my W, I'm gonna write it over here somewhere. W equals 80. W is 80, so what's my L gonna be? 80 plus 30. 80 plus 30 is 110. And it asked me for the dimensions of this field, so I'm gonna do 80 times 110 is my dimensions. Ooh. This is kind of messy today, but that's okay. 80 times 110 yards. So this is my answer over here. Okay, any questions? We're gonna hit 60 next time I see you. We're gonna hit 61 next time I see you. I just wanna preview what this last one looks like because we don't have time to solve a full problem. So let me just set this one up so you kind of have an idea of what's going on next time we have class. This one says find the center and the radius of this circle. Well, we would have to have it in terms of x minus h squared plus y minus k squared equals r squared. You guys were really good when I just gave it to you in this form. You could easily identify the center, easily identify the radius. We are not there right here. In order to get here, we need to put our x's next to each other. X squared minus 8x, leave a blank. And then my y's together, y squared plus 10y, leave a blank. And then that equals 5. What I'm gonna have to do in order to get it to this x minus h squared, I'm gonna have to complete the square for my x's and my y's. I'm gonna have not just one blank on the right side, I'm gonna have 2 blanks. So whatever fills this blank is gonna be added here. Oh, I'm writing and talking and you guys can't see it. Let me move my screen. I'm so sorry. I wrote like a whole bit. Okay. So whatever you add right here goes in this blank, and then whatever you add here is gonna go on the blank behind it. So what I'm gonna preview and what we're gonna do next class is we're gonna complete the square twice in order to solve this problem, okay? I'm gonna stop my share now. I am all done teaching you guys today. I got to make sure I keep attendance, so let me take a picture of that. Okay, I'm going to be done